So now let's start with the next chapter, signals and systems. So most of the things we have already discussed. We have discussed about the signal. What is a signal? Signal is a set of information or data which changes with time. And what is signal processing? Signal processing is it is a method of extracting information from a signal by carrying out some algorithmic operations, or we can also say the mathematical operations. Okay, on the signal, it is dependent on the type of the signal and the nature of the signal it carries. Okay, analog signal processing, we have the input signal which is analog in nature. We have electronic circuit. Okay, then we get processed output signal. Okay, this is for the analog signal processing. Now analog circuits, they have their certain disadvantages. There is power loss. With aging, the component value may change. Okay, their performance may change. So because of that, nowadays digital circuits, they are being preferred. And why they are preferred? Because they are less sensitive to changes in the component values. Okay, because you are digitizing it and then you are doing all the operations in the digital domain. If you see, whatever the computer you are using, if you do the mathematical operations today, and if you do the same mathematical operation after say 10 years, the results will be the same. It will not vary, right? So it is not dependent on the component values. Then it is also less sensitive to the temperature. Temperature would not have effect. Whereas if you are talking about the resistors and capacitors, they may have their own they may have their own problems, and with aging their value may change, and it may affect the results. And there might be some external parameters like humidity, and say for example, if you are having some light sensitive sensors like LDR and all these things into your analog circuits, those values would be changed. But over here in digital circuits, there is no chance of change of those values. Hence digital circuits, they are being preferred. So due to this reason, they offer the digital circuits, they offer certain advantages. What is that? Flexibility in reconfiguration of the DSP operations. Okay, so many of you must have heard of these microcontrollers, right? Say for example, nowadays we use Arduino microcontrollers. Okay, so in the Arduino microcontrollers, what we have today, we run some program. If you don't like, after some day, say after some time, say 1 hour or 2 hour, you can again put in some fresh program, and you can test that program again tomorrow. If you don't like, you can change the program and you can update the program as per your liking. So over here, you can reconfigure the digital signal processors quite often, which is not possible in the hardware domain. Suppose if you have made a filter and you don't like the operation, you are not liking the operation, again you have to go back to the uh, board, and you have to calculate what should be the these component values and all these things to design another filter which would meet your specification, right? So over there you have a you have to take a lot of pain to design a filter. However, in DSPs, you just write a program. I need this filter, this thing, and you are done. You will be able to do it. Then accurate. In a register, if you say that I want to use a register, they come with 5% tolerance. So they come with 10% tolerance. So we use registers with some values. Say for example, if we are having 1 kilo ohm resistance, the 1 kilo ohm, it may be 990 ohms, or it may be 1.01 kilo ohms, like that. It would vary. Okay, it is not possible to make a specific 1 kilo ohm resistance. If you are getting a resistor of 1 kilo ohm, you are lucky. But it is not the case in most of the thing. Even the highest accuracy resistors, they would be having a resistance of say 1%. Okay, but the cost will be multiple times higher. Okay, so if you see, the same happens with your the inductors, same happens with your capacitors, right? So Analog circuits, designing an analog circuit, it is very difficult because you will not get accuracy if you try to mass scale it. However, if you use the digital circuits, you are just doing the coding, you are just writing, do these operations, everything is fit, and whatever the input it would get, it would just give you the output, mathematical operations, right? Then easy storage of data. We have this thumb drives now. Now we have 2 TB, 5 TB hard disks also. You can store the data easily. Whereas in analog domain, you have to use large capacitors and all these things to store the analog values. And lastly, cost effectiveness. Nowadays, if you see 1 TB hard drive, it hardly comes at around 3,000 rupees. Okay. However, if you want to design such a large scale of storage for with the analog domain, you would need a large space to store the components itself, okay, and the circuits itself where you can store the data. So in all these things, if you see the digital circuits, they have much advantages, and hence they are more preferred over the analog signal processing systems. Then digital signal processing, it is a part of it's one of the part is the biomedical signal processing, and we have already discussed in the applications chapter, so I will not go into the depth of this one. If you have any doubt from this flowchart, you may please ask. Anti-aliasing filter, okay. I told you that while we are acquiring the signals, so what happens, we do the band limiting, right? So anti-aliasing filter is the band limiter, okay. So it is a basically, in most of the cases, for the case of biomedical signals, it is a low pass filter. So suppose you are having this ADC which can sample at 200 hertz, then this anti-aliasing filter, it will limit the bandwidth of the signal in the range of 0 to 100 hertz. Okay, I told you that your sampling frequency should be greater than equal to 2 of fm, right? Here fm is 100 hertz and fs is 200 hertz. Okay, so this is the limiting factor. Again, there is one reconstruction filter over here. What is this? This is again another low pass filter. I don't know how many of you have seen digital signals. If you take the digital signals from any of the microcontrollers and it does not have the digital to analog converter, you will find that the signals what you are getting are just like staircase signal, like this. Okay, they appear like this. But if you are trying to design, if you are trying to get this analog signal from the output, then what we need to do, we don't need this staircase type of signals. Okay, so we apply this low pass filter, which is basically a reconstruction filter. And then, what is a reconstruction filter? It is basically a moving average, and it smoothen out these points, and it would give you an envelope. Okay, so you get an envelope which would give you a um, analog signal, which would be similar to your original signal. Okay. Now, advantages of the DSP, we have already discussed many of the points. Guaranteed accuracy, flexibility, superior performance. There would be no drift in the signal. Adaptability, you can adapt it if you are trying to design these adaptive filters. These DSPs, the signal processing units, they will adapt according to the input of your signal. Okay, input signal. Then perfect reproducibility. Then multiplexing. What is multiplexing? Anyone? Multi means many, plexing means mixing. So if you have say signal from say sensor one, say temperature sensor, say humidity sensor, say pressure sensor. Okay, so you can put all this data into a single DSP, and you can program it to isolate the all the three data, and it can process all the three at the same time. Okay, which is not possible for the analog signal. For temperature sensor, you need to develop one signal conditioning unit. For humidity sensor, you have to develop one signal conditioning unit, and then if you want to measure pressure also, you have to do another thing. So depending upon how many ports are available for acquiring the analog data into your DSP. DSP means digital signal processors. You will be able to acquire multiple data into the system and then process it uh, simultaneously. Okay, so this gives you an added advantage. Then data logging. Data logging means storing the data. You acquire the data into the system and then you store it into your thumb drive or hard drive, wherever. So nowadays, if you go to the go for this X-rays or MRIs, you will find they are collecting the data and then they are giving you the printout of the whatever the data they have collected, whether it is MRI images, whether it is your what you call this X-ray images, whether it is a CT scan images, whether it say it is a what you call this ECG signals. Okay, so how they are printing? Basically, the data is being stored in the DSP, and then a print of that data is being generated. Okay, then low frequency capability. Uh, in this using the analog domains, if you are having drifts within the signal. Okay, drifts means these are basically slow changing signals where the baseline it changes. Okay, so these drifts they can be minimized if you take the data into the digital signal processor. Okay, so uh, handling the low frequency components is very difficult. It's, in the what do you call that, in the analog domain. Okay, because as I told you, the variation in the component values, it may itself may generate some low frequency this drifts. Okay, now once you take this data into the digital domain, you can accurately remove the drifts by applying the low frequency filters. Okay. However, there are certain disadvantages of the DSP. So, increased system complexity. If you want to design a DSP, if you want to develop an Arduino microcontroller yourself, it would be very difficult for you. You have to learn the microcontroller programming and all these things. You may have to add up some other additional components. You may have to add the ADC. You may have to add the DAC into the system. So designing the DSP, it is a bit difficult. However, if you master it, it becomes easier. Okay. Then speed and cost. If you want a very high speed DSP, then its cost also goes up. Whatever the Arduino microcontroller you see around, they come at a price of around 400 500 rupees. Nowadays, the price has gone up to 1000 due to this mm, this Russia-Ukraine war, and there is a global shortage of stuffs across the global shortage of stuffs, and due to this reason, the cost of these components have also gone quite high. So, due to this reason, even these Arduino microcontrollers, they are costing you at around 1000 rupees. Okay, so this is one of the major problem of this thing. So think of the stuff. It is just costing you. Uh, Even today, if you want to procure it, it will cost you $1,000. Okay, not more than that, and you can do wonders if you are trained in this Arduino, and even with Arduino, microcontroller, especially for your MTech projects, right? Then there are other systems. There is a better system from this one. Say there is a Raspberry Pi, which is a single chip computer in itself. Okay. Now, if you use the Raspberry Pi, previously it used to cost around 3,000 bucks. Okay. So you see, Arduino, it costed you approximately 300 to 500 rupees, and it costed you at least say seven times higher, 1500, right? Now the thing is that not yeah, five times higher, not seven times. Sorry. So, uh, so what is happening over here? When you went for a better performance, this digital signal processor, your cost has increased five times. Okay. Now at the current day, what we used to get at around say 3000 rupees, uh, now the cost of the same this Raspberry Pi, it has gone to approximately 15,000 to 16,000. You see the jump because its utility is more. There is a shortage, so demand has increased a lot more. So the prices have skyrocketed from 3,000 to 15,000 or so. In this way, when we talk about this Raspberry Pi, is it the ultimate system? No. Raspberry Pi is for the hobbyist, right? It is not for the persons who are into the industry. Industry people they also use, but they use a high performance system. So as you go up, as the performance of your digital signal processor increases, your cost also increases. Okay. Now you can, from this low end microprocessor, digital signal processor, you can have an estimate if their prices have gone so high. So how would be the prices of the high performance systems would have gone, right? So this is the thing. If you want speed, you can get speed, but you have to pay for that, right? Then there are finite word length effects. So what are these? These are the things when we are having the analog signals, then what we do? We first discretize the signal, then we quantize the signal. Okay. So when we are quantizing the signal, uh, we are fixing the voltage values. Okay. In the digital systems, you will be having some specific uh, voltage values. What the voltage can what do you call it can be stored. Okay, outside those specific ranges or specific values you cannot store the data. So what is happening, suppose you can store a voltage of 0, 1, 2, 3, 4, 5. So what happens if the voltage is 1.5? Then it is rounded off to 2. If it is 1.49, then it is rounded off to 1. So there is a rounding off error. So this is one kind of finite word length effect. Then again, suppose you are multiplying two numbers. Say for example 2.1 and multiplied by 2. So what do you get? 4.2. Now 2 multiplied by 2, it is also 4.2. Sorry, it is also 4. So isn't there any difference between 4.2 and 4? It is a difference. Again, we do not have the capability to store 4.2, so we have to store it as 4. So this kind of errors it is coming down. So there is this product error. There is this quantization error. Okay. So in that way, when you are working in digital domain, there are many types of errors where you have to round up the system and you do not get the accurate values. So these values, these errors, they are regarded as finite word length effects. Okay. Now, comparison between the analog signal processing and digital signal processing. Analog signal processing is fast. Digital signal processing, it is moderate. Cost low to moderate, and this one is moderate. Flexibility low to moderate. Flexibility is high. Performance is moderate. Performance is high. Self calibration, it is not possible in the analog signal processing. However, in digital signal processing, it is possible. Then data logging capability, it is not there. Over here it is there. Adaptive capability, it is again it is not there. However, in digital signal processing, we can use it for the adaptive purposes. Now the applications, business. In the business, If you see the stock market, it is, I am giving you one of the examples. If you go for the stock market, this thing, so what happens? This ARMA models, they are this time modeling, they are used for time modeling and prediction of the future values. So these can be used to predict the stock prices and do the business. Okay, this can be used in other stuffs also. Then coming to the science, those who are from the biotech backgrounds, they might be knowing that you need to design bioreactors. Okay, so how do you control this bioreactor? So bioreactors have different things. You have a stirrer which would be regulating the mixing within the stuff. Then there would be pH sensors, there would be oxygen sensors, there would be say temperature sensors. All the things have to be monitored, and based on the parameters you need to again control back this bioreactor again, so that the input of the feed or uh, the output of your product, whatever you want to do, all these parameters can be controlled. Okay, so it helps us in doing that. So in that way, this DSP can help us in getting a better productivity of whatever we are producing. Then coming to the industry, many of you have learnt about, know about this Asian Paints. It is a household name in India. Okay. Does anyone can tell me what they do differently? Why they are so great? And they capture around 70 to 80% of the paints industry in India. Any idea? Since 1970s or 1980s, they are applying machine learning models in their distribution chain. Okay, how they are doing? Suppose you want to uh, go and buy, say, this adapter from the market. You have the manufacturer. From the manufacturer, it goes to the wholesale dealer. From there, it goes to the retailer. Okay, so from manufacturer to retailer to the consumer. Okay, so who is the interface between the consumer and the industry? Basically, the retailer is the interface between the consumer and the industry, right? So they told what is the need to have this middleman between the retailer and the industry. If they can eliminate these stockists, what they do, the distributors do, they basically stock, and hence the name comes stockists, right? So what these stockists do, they would buy the different products from the Asian Paints, say for example, the Asian Paints, and they would have stock. But how do you know what product a particular consumer would need? So they implemented, Asian Paints implemented supercomputers even before any of the IITs of India, they were having supercomputers. And they took a pledge, we will remove all these middlemen. And what they are doing, they are having the retailers, and they are giving their material to the retailers at a very cheap price, because the middleman has been eliminated now. Now what they are doing is that they collected data from the retailers, that at particular day of a particular year, what is the requirement of the which type of paint, because they are having a large number of paint. The paint quality varies, the color of the paint varies. So they have collected the data, and they have fed it into their supercomputers, and then they have applied the machine learning models. Now they can accurately predict at, say, outlet number one, what any particular day, what paint would be sold. Okay, why? Over the years, as the current day progresses, again they have this data in their server. Are you getting my point? Every day their algorithm, it refines itself. In fact, if you go through the YouTubes, you will find the retailer also don't know what would be the input from the industry to them, what product they will be getting. The retailer does not know. Okay, then who is sending to the retailers? The production unit. You go to the production unit, you ask the production manager, he also doesn't know what he should be producing today. Okay, he says when I come to the this my what you call this production plant, I already get an email that you need to produce this one. If you go to his manager, he will not be able also be able to tell you what you have to do, what things or what steps they should need to implement. Now you see, this is the power of DSP, and since they are having the data for all the consumers and they have collected the data for so long period, what is happening, that is a mode for them, that is a mode for them, and that is how they are beating the other competitors. We talk of Burgers and all these things, all the other paint companies, they stand nowhere against Asian Paints. Okay, because of this simple reason, what their founder took it, say decades ago. Okay, so you can see industry now military. You think of the China. I don't know how many of you follow this world news. You will find China is preparing for AI wars. Okay, why? Because that will give you advantage. What is our BrahMos missile doing? It moves at supersonic speed, right? No doubt. But it has got a digital signal processors within it, which helps it to change their track. Okay. So if you see these DSPs, they have entered into the military systems also. Okay. You think of the communication. We are launching satellites. What do they use? Do they use analog signal processing? No. They use these things. If you see the mobiles, it can do wonders. It can do starting from simple calculation to many things. Okay. Then in medicine, digital signal processing, how it can help. I gave you the examples. It can help you in rehabilitative medicine. It can help you in diagnosing the diseases. It can help you in what you call in uh, controlling certain yeah, parameters or predicting something, right? So uh, in the medicine also it can be used. One is diagnosis, second is treatment, that is rehabilitation. Okay. So then again space and communication, they are related. It can help you in collecting information from your enemy territory. So how did India know in the Galwan Valley, post Galwan Valley, that China is uh, uh, making their position strong in the Galwan area? It was through the images what our Indian satellites they have procured, right? So a big thumbs up to our ISRO. They are doing wonders. Even your military organizations like DRDO, many of the DRDO units, they have developed many missile units. There is a unit, this missile defense system, which is regarded as KALI. KLI. This is one of the best missile system indigenously developed by India. Okay, so you can see these digital signal processors, they are helping us in various ways. Now coming to the classification of the signals. Yeah. So classification of the signals: continuous time and discrete time signals, analog and digital signals, real and complex signals, deterministic and random signals, even and odd signals, periodic and aperiodic signals, energy and power signals, and lastly causal, non-causal, and anti-causal signals. So these are the broad classes of signals, right? So what is continuous time and discrete time? Continuous time signal. So say for example, you are collecting a temperature data. So you put a thermistor and you just look into the CRO. You will continuously get some reading. Okay, so that is a continuous signal because we are working in the continuous time domain. Okay. Now, if we multiply this signal component with a impulse train, what is impulse train? So it comes from impulse signals delta t, which is having a value of 1 at t equals to 0. Now, what is impulse train? Impulse train is nothing but okay. So, sorry. So, what does this say? This say you are having values of at t equals to 0, t equals to 1, t equals to 2, t equals to 3, and so on up to infinity. Right? Now, what does this say? Okay, what does this help? So, suppose you are having xt, and if you multiply by delta t, say for example, we are taking x0, xt multiplied by say delta 0. So what we will get? We will get value at x0, whatever is the value at t0. Okay, so at t0 whatever is the value we will get. Then if you do this 0 1 2 3, so if you do this whatever is the value of this one with this impulse stream, you will get that value. So this is say x1, x2, x3. So in this way you are able to discretize the signal. Okay, because in between 0 and 1 there will be nothing, right? In between 0 and 1 there would be nothing. So you are having at 0 some value, at 1 some value, at 2 some value. Okay, so when we are having when we are multiplying continuous time signal with the impulse train, so we are converting the continuous time signal into a discrete time signal. Okay, so this process where we are multiplying the signal with the impulse train capital T, this is this process, it is called sampling. Okay, so once you do this we get the discrete time signal. Now discrete time signals, they can be represented in this values in the form of equations or this thing a series. Okay, then it can also be represented in this fashion. So over here you are having say a series of number, then we are having a pivot. What is this pivot? Wherever this pivot is present, that means your time value at that instance is 0. Okay, wherever there is a pivot, that means the time value at that point is 0. Okay, then we can go for sum and product of two sequences, we can go for summation, we can go for multiplication, we can go for again multiplication where with a constant. Okay, these are the two main things. Addition, you can replace this addition with the subtraction also. Okay, now how to do this? So suppose you are having two signals, this one and this one, right? So if you add it up, so what you have to do, you have to see that these pivot points they match together. Okay, so coming over here, so I have first written 13546, then This pivot point should match over here. So under 5, I have put 2 and I have just placed the values. Now you do the addition. Okay. Now you do the addition just as it is. Where you will put the pivot? Your pivot should be here. Okay. It would be very quite basic for many of you, but there are many other students. For their sake, I am just repeating this. Okay. Coming to the multiplication, same thing. 5 multiplied by 2, 10. 3 multiplied by 3, 9. 4 multiplied by 1, 4. 6 multiplied by 4, 24. Okay. If you have to multiply it with a constant, you just multiply with the thing, say x1n. 4 multiplied by 5, 20. So the next thing is that if you think about, suppose you are given with something like this. So 5, 7, 2, 4. There is no pivot. So which one would be your origin? The origin would be the first one by default. If nothing is given, no pivot is given, then your first number, it is the origin. Okay. So when we talk about xn, what is n? N is the time value in the discrete domain. So we write it as same x0, the value of amplitude value of the signal at n equals to 0. Similarly, we get x1, x2, and so on. And herein we get on the left hand side x minus 1, x of minus 2, and so on. Right? So if we are having xn like say x1 and 1, 2, 3, 5, then the time index n should be equal to 0, 1, 2, minus 1, minus 2. Okay. So this is the time value. Now analog and digital signals, there is a confusion between many of the students. I would give you two statements. Continuous time signals, they are analog system, they are always analog signals. And two, all analog signals, they are continuous time signal. Which one is true? We interchangeably use, right, analog signals and continuous time signal. Now there could be two statements: all continuous time signals, they can be analog signals, and all analog signals, they can be continuous time signal. Which one is true? All continuous time signals are analog signals. Then what is the wrong in the second one? Why? Uh-huh. What are analog signals? What are analog signals? Analog signals by definition means the signals whose amplitude can vary from minus infinity to infinity. ये दिमाग में डाल दो, ठीक है? If you consider the previous thing, we have sampled it in the time domain. That means whatever is the amplitude value, we are just multiplying with 1 at specific time intervals. So continuous time signals, they can have value in the range of minus infinity to infinity. Okay, the same thing happens over here. So इसमें ये भी होता है, say for example 0.001, ये जो delta x है, that is also included over here. Okay, so it can attain any number of points basically. Okay, minus infinity to infinity means any number of points, any value. So whatever the minimal delta x value you can imagine or implement in analog signals, you will be getting that. So all the continuous signals, it will be getting there. All the discrete time signals, they are also analog signals because they can also attain any of the values. Okay. Whereas in the digital signals, we quantize the amplitude levels. Okay. So if you see, sampling followed by quantization or the rounding off. Okay, so when we are rounding off, I told you, when we are discussing about digital signals in the preliminary thing, I told you it can attain only certain specific values. Okay, so when you are rounding off, they become the digital discrete values you are getting, they are called digital signals in the amplitude levels. Okay, now in most of the cases you will find that the a digital system, it can accommodate the signal in the range of say minus 5 volt to 5 volt, or minus 10 volts to 10 volts. Okay, so what should be the delta v value? Okay, so suppose your system works in the range of minus 10 to 10, so we will take the modulus as 10 for both the thing. So we get delta v equals to 2 multiplied by 10. I am coming to the denominator a bit later, so it comes out to be 20. Now if I say it is 4, 4, we get a delta v value of 5. Okay, so let us draw. At the bottom we are having, at the mid we are having 0 volt, sorry, 5 volt, 10 volt, then minus 5 volt, minus 10 volt, right? Now one, so how many sub intervals will be having? 1, 2, 3, 4. Okay, we'll be having 4 sub intervals, and that is what it is given. Okay, now how did this 4 come? This 4 came from 2 to the power n. Okay, so if 2 to the power 0 is 1, so it is a 0 bit system. So 0 bit system doesn't occur. So we will start with 2 to the power 1, 2 levels. So it would be 10. So we would have minus 10 volt and 10 volt. And in between you would have the reference. Then 2 to the power 2, you would have this 4, 5, 4. Then if you have 2 to the power 3, 8 levels. Okay. In this way, if we go and see most of the signal processing units in the current day world, you will find even the Arduino Uno, they are 8-bit image, 8-bit processors. Okay, 8-bit means 2 to the power 8. Okay, 2 to the power 8 कितना होगा? 256. There would be 256 levels. Okay, there would be 256 levels. Then there are 16-bit systems also. 16-bit systems, they are quite costly, and usually for hobbyists and for normal things, even for this biomedical signal processing stuff, we have seen 8-bit systems are good enough. Okay, so I hope you have understood the difference between the analog signals and digital signals. If you see analog signals, they can take an infinite number of values, whereas since we are sampling and then quantizing the signals, the digital signals, they would be having some specific values. Then real and complex signals, real signal, all the signals what you are acquiring, they are real signals. However, in the complex signals, you will be getting this j, which is a complex number, nothing, some would say I. Okay, so it is nothing but under root of minus 1. Okay, so how do you get it? If you apply Fourier transform on xt, you would be getting f of j omega. And if you perform something and go back, you might get some signals which are having j components. Okay, so any signal which is having j component within itself, they are complex signals. We do not use it, but for the sake of your knowledge, you should keep this in mind. Then deterministic and random signals. Deterministic है just like a good boy, he will get up, he will be having a particular what do you call, timetable to follow in a day. He will get up, he will go to school or college, he will come back, he will revise and all this thing. So he is leading his life in a systematic manner. So systematic means in a mathematical form, in a particular order. If he is leading the lifestyle, then he or she is leading the lifestyle. Similarly, if a signal, it is following a specific mathematical formula, you can predict what it would be doing the next day, again in the next day. Then those kind of signals, they are regarded as the deterministic signal. Okay. Random signals, uh, they don't follow anything. Today, they might feel I will go for swimming at this time, they would go for swimming at this time. Next day they may feel I would study, they would study. Again the next day they would feel that he or she will go for playing cricket, they will go for that. So they do not follow any rule. So signals also, if they are not following anything, then those signals, they are regarded as random signals. Okay. And how do you um, quantify them? We quantify them using certain probabilistic description like mean, mean squared value, median, all these statistical parameters. Okay. The time is okay. Okay, then we'll continue in the next class.